Now we are going to evaluate this double integral. See here the order is given by dx dy. First we have to integrate with respect to x. Okay. And we have to keep this variable y as a constant. So the first step is we have to write the constant together. So write outer integral as it is. Inner integral 0 to root of 1 plus y square dx. Okay, so y is the constant now. Okay, so write this y and 1 together. 1 plus y square plus x square dy. So first integration with respect to x. Now it is of the form, this formula, very well-known formula, dx by a square plus x square. So which is equal to 1 by a tan inverse of x by a. In the place of a square, what we are having is 1 plus y square. So a square equal to 1 plus y square. Okay. So what we do, write outer integral as it is 0 to 1. 1 by a. A is root of 1 plus y square tan inverse of x. X by a. A is root of 1 plus y square. Here the limit is, what is the limit? 0 to root of 1 plus y square dy. Now we have to apply the limit for x. So 0 to 1, write the y term as it is 1 plus y square tan inverse of, apply the upper limit. Upper limit is root of 1 plus y square by root of 1 plus y square minus, apply the lower limit, that is tan inverse of 0. So here we have to substitute the limit for x, okay, into dy. So here it is become tan inverse of 1. We know tan inverse of 1 is nothing but 5 by 4. So 0 to 1, 1 by root of 1 plus y square into 5 by 4 dy. Okay, now the inner integration is over. Now we have to do for the outer integration, that is with respect to y. So take the constant outside, 0 to 1 dy by root of 1 plus y square. Again we have to apply the formula. So what is the formula here is integration of this one is 5 by 4 log of y plus root of 1 plus y square. Okay, so integration of this one. Integration of dx by root of a square plus x square. Now apply the limit. Apply the upper limit. Okay, upper limit is 1 here. For y, we have to substitute 1. So which is equal to 5 by 4 log of 1 plus root. When we apply the lower limit, it is log 0. Here it is also 0. But log 1, we will get log 1 is nothing but 0. Okay, so this is the answer. So next we do the triple integral. Evaluate triple integral 0 to a, 0 to b, 0 to c, x plus y plus z, dx, dy, dz. So here the integration is very simple. Why it is very simple means, see the limit. All the limits are constant. Okay, the limit has no variable. So first we have to integrate with respect to x. So we have to keep this y and z are constant. Okay, so write outer integral, middle integral as it is. Okay, integration of x is, we know, x squared by 2. Second term y. Y is the constant. Write y as it is. Integration of y is yx. and integration z also constant. So the integration is zx 0 to c dy dz. Now apply the limit for x. Okay, 0 to a, 0 to b. So x equal to c square by 2 plus cy plus cz dy dz. So the inner integration is over and also we applied the limit. Now we go to the middle integration. Middle integration is with respect to y. Okay. So the other variable is only z. So we have to keep this z as a constant. Okay. Write outer integral as it is. The first term is c square by 2 which is constant. So the integration is c square by 2 y plus c. The integration of y is y square by 2. The third term cz is constant. So integration of the with respect to y is y. 0 to b dz. Okay. Now apply the limit for y. 0 to a c square by 2b plus cb square by 2 plus czb. Okay, we are applying the limit for the variable y. Now we go to the last integration, that is outermost integration with respect to z. See our function. This function has only the variable z. The remaining all are constant only. Okay. So now first term is c square b by 2. The integration is c square by b by 2 z. Second term c b square by 2 which is constant. So integration is with respect to dz is z. Third term CB write as it is. Z integration is z square by. Now apply the limit for Z. So C square B A by 2 plus CB square by 2 A plus CB A square by 2. Now we can take common also to simplify. If I take common A, B, C by 2 means what you will get? A plus B plus. The next problem, evaluate integral 0 to 2 pi, 0 to pi, 0 to a, r power 4 sine phi, dr, d phi, dt. See this problem, it has a, instead of x, y, z, we are having r theta phi, which is nothing but spherical coordinates. Okay, whatever it may be, the first integration is with respect to r. We have to treat the other two variables. What are the other two variables? Phi and theta as constant. Okay. First step, what to do? Write outer integral, middle integral as it is. Here, we have to integrate with respect to r. So, write sine phi as it is. R power 4 integration, r power 5 by 5. The limit is 0 to a. D phi d theta. So 0 to 2 phi, 0 to 5 sine phi. Apply the limit means we will get a power 5 by 5 d phi d theta. Now the inner integration is over. Next we do for the outer integration, that is with respect to phi. Here this a power 5 by 5 is constant, so take outside a power 5 by 5. 0 to 2 pi. Sin phi integration we know minus cos phi. The limit is 0 to phi d theta. Okay. So take this minus sign outside. A power 5 by 5. 0 to 2 pi. Apply the upper limit cos pi minus cos 0 d theta. So we know the value of cos pi is minus 1. and cos 0 also minus 1 d theta. So we will get minus 2. So taking outside, it will become 2a power 5 by 5, 0 to 2 pi d theta. Now we do only the last integration, outer integration, that is with respect to theta. Here there is no other function, so we have only d theta. The integration of d theta is theta. So when we apply the limit, what will happen? 2a power 5 by 5, 2 pi. So which is equal to 4 pi a power 5 by, so which is the answer.